training accounts. Now, is everyone over here on the call able to access Setonix?
Yeah, so in order to follow the exercises on Setonix, we'll have to get access to Setonix through the Courses 01 project. So although you might have already your accounts available on Setonix, through Courses 01 you will be able to get access to Setonix GPU nodes, which we want to use for the training. And that means that I will need to share with you a similar spreadsheet that we had for AWS, where you will find the login name as well as the password. So just give me a second. I need to find it out, and I will share that in the chat. So I have just posted the link to a document where you will find the details of how to log into Setonix so that you can use the GPU partition for the training. So please have a look at it and put your name there. And Pawsey staff should be able also to do that through their own accounts. And other participants of the training, please grab the Setonix username from the spreadsheet that I just shared. Also, if there are any questions, please. Cool.
Setonix on 2 nodes.
Also, if there are any questions, please feel free to unmute yourself or ask it on chat. Also, something that most of you might not be aware of, but through the participation in the training, you are actually the first users of Setonix GPU partitions.
Okay, just to make sure that we can do similar things with E4SCL as we did yesterday in the AWS instance, I have a run file and I'm looking for a volunteer who can just run this on their own login and see if it works properly for you. This is running E4SCL on Setonix, but after you, so here is the run.sh. So, Alexis, maybe you can take this and copy this run.sh script in your directory and try running this example in a scratch space where you don't have anything else. Maybe somebody else can also try this. Copy this run.sh script and then first allocate 2 nodes and then run this run.sh. And to do that, you will just look at this run.sh and you'll do an salloc like this. So do this salloc and then do a /run.sh. And let me know if this works for you.
Samir, could you maybe we can do a quick check also online if everyone was successful logging to Setonix, because there were some questions. So
yes,
if you still have issues, please let us know.
And this is building on what we did yesterday, where we were running the E4SCL tool to substitute the MPI in a container. We started with this Zoltan application yesterday at the end of the day, and we substituted the MPitch in the application with OpenMPI. Now we are going the opposite way. We have an unmodified container that Alexis has downloaded, which has OpenFOAM in it. And we have 2 nodes allocated with this slloc command here. And what we were trying to do is use E4SCL and run this container on 2 different nodes using the Cray MPitch. And we load this E4SCL module and run it and launch the execution on 2 different nodes. So if somebody can just confirm that this works for you on a scratch, in a scratch directory, please do not copy these files in your home folder. Please go to a scratch directory where you have space and copy this run.sh script. And then if it works, then we will have this E4SCL tool running locally on Setonix.
Would you be okay, Samir, to show how to go to the scratch directory for those
Yes.
that might be first, but using Setonix for the first time, just to do the commands that you said, to cd to.
So you can go to a scratch folder, or you can go to the project folder that you may have.
Yeah.
So if you have a project folder, like I'm using software projects courses 01. And then within this directory, I have a subdirectory called paratools. If you are part of the courses 01 group, you can create a directory within the courses 01 for yourself. And in that directory, if you copy this file, which is located here, then allocate 2 nodes using this slloc command. You can just cat this run.sh, cut and paste this slloc command, and then run this .run.sh in the courses 01 folder.
So one person reported that there is an issue with permission.
Permission denied for which directory?
For a binary which is called sample_mpitch, and that's sitting in /software projects courses 01 paratools E4S, then E4S CL install.
Let me just make sure.
I can show you.
I think it's the it's.
Yeah, there is no explicit permissions on that one.
Permission denied in the, okay, so I'm just running this chmod command. And
yeah, that should work.
It should fix it. And once this works, then the permission. That's why I was saying I need a volunteer, because there's always something. There is the chmod. As soon as this finishes, I think it should work. Yeah, it's all under the E4SCL install.
It's the same.
Yeah, it's just
And I also posted in the chat that to go to scratch space, you can actually use the environment variable that we have set up on the system, which is called myscratch. So you can just do cd $myscratch, and that will place you in the scratch directory. Then you can copy the run script that Samir have shared and try to run it from there.
So this should just take a minute, this chmod command, and then we should be able to run it. Yeah, that's good. And if we move this paratools module in the modules file directory to one of the other central areas, we won't have to use the module use command, but we can do a module load paratools directly. And while this is running, let me just wrap up what we were doing on AWS with creating the container with Singularity. And you'll see that this Singularity build is now complete. And I can say exit from here. And I should have this container where I can say Singularity run Ubuntu mpi.sif. And this will run this command, which was there in the Ubuntu mpi.def file. You see, this is the echo that we started with this bootstrapping from Docker, creating this new container called Ubuntu mpi.sif. And with this, you can create your own Singularity container. In Singularity, we can use the -b flag to mount a directory. So you say something like Singularity run -b $home. It will mount it as $home if it's not already there by default. And then you can give the Ubuntu mpi.sif. You can look at the rest of the examples. We have another container like this with the hello.def, where I take the MPI application and then I inject it again inside the container like this, hello world.c, and then I compile it into a hello, so that when you run it, I have this run script and then this MPI run with the hello. And so when you run this again, Ubuntu, hello.def file, and create a new file called hello.sif, you should be able to say Singularity run hello.sif. So I hope you can try running this as well. And you can see the results of this hello.sif, where you're running the hello world application and it points out what nodes it's running on. This is strange that it's taking so long for the chmod command. Is there a file system problem?
No problem, but it takes really how many files here?
It's
Not sure how many files you have over there, but I think there was only a single file that was reported that had wrong permissions. So maybe you can kill that and go into the because that was sitting in. Let me see. So it was e4scl install, but then system precompiled binaries, and basically in that directory, if you run the same command in that directory, it might be easier to fix that. So, yeah. Yeah, and then install, and then system precompiled. Oh,
it's just stuck. It's not going in the cd command. Just the ls is hanging. There's some file system. There is a file system problem. Otherwise, this ls should have come out. But at least we know that it's working once the file permissions are fixed. It's working for me. And this is the precompiled binary sample mph. Okay. there is a slight problem here. But let me just turn my attention to the online participants. Were you able to create the containers with Singularity? Were you able to launch these containers? And I asked this because the next step with the containers is that we move on to a full-featured container. So we covered the basic containers, how to create a Docker container, how to create a Singularity container, one which has an MPI in it. And then we look at a base image. We have the E4S a la carte tool that we will have later. And then we can start with a full-featured E4S container. So I see the chmod has completed. Can somebody confirm that you are able to run this job with E4SCL? Again, the parameters are so. Marcia, can you just try copying this file, this run.sh, get two nodes, and then just try /run.sh.
I can see that Angus just confirmed that it's working for him now. So
Who's confirmed?
Angus, who's connecting online, and Stefan as well.
Stefan as
Looks
well.
yeah,
Okay,
looks to be working for me too. So it seems to be good now.
it's up and working now with the it was just a file permission problem that's resolved, and you can also confirm if you have the run.sh in the two nodes. We can, of course, tweak the number of cores and parameters. I think the problem required 8 MPI ranks total. So we said 2 nodes and 4 ranks per node or something. Just and then again, going back to the issue of using the big container, on AWS, I can start with Singularity run with the E4S ecp.simg. And then once I'm in the container, I can say in Zoltan directory, clean.sh, compile.sh, and say run.sh locally. And what I'm doing here is running this Zoltan application on AWS with this Singularity container. And with this, it's 10:23. We will shortly take a break. But
There is also a question from Sarah online.
what is the question?
Because her WebEx session crashed and she wasn't able to follow up with the commands that we were running on Setonix.
On Setonix?
Would you be okay to go through it again?
I'll show this again. Yeah.
Thanks.
So here is the directory where I have a run.sh script. So I was going to my scratch directory, which could be my scratch, right? Here is my scratch. And then I was copying this run.sh to my scratch. And let me just, here. So cd to $my scratch, followed by copy this run.sh script to the current directory. And then if I look at the run.sh file that I have copied over, it shows you this slawk command. I run this slawk command over here, and then again I go back to this my scratch directory, and then I will do the run.sh. Is this okay?
Checking with Sarah.
Yeah, that's great. Thank you. So do you do the run slawk or do you just do the run.sh?
So I first do the slawk. I'll get
Okay.
the two nodes, and then in that directory, I'll just do a /run.sh.
Okay. Oh yeah,
Okay.
cool. I can see you've logged into the node. Yeah. Okay. Thank you very much. Yeah. Sorry,
Sure.
I'm hotspotting because I've just moved and the internet's not working. So thanks for that.
I hope this will allow the OpenFOAM to run on the two nodes, and you'll be able to get output from the run. And I hope all the file permission issues have been resolved.
So I have a question about that OpenFOAM run that we are doing. Is that through the container?
Yes.
So is that the Infinity Hub container?
It is.
Okay. No?
It is. It's not the Rockham container. This is a container which is just having MPI version of the OpenFOAM package.
Sorry.
Yeah, I hope we can do the Infinity Hub test later today, but this is a first test. So this container comes from OpenFOAM developers, and they provide the containers with OpenMPI. So it's an OpenMPI container running on Setonix, and it's only using the CPUs. But yeah, the Infinity Hub container is also there. So I guess we can just switch to the other test and run it.
Absolutely. Yeah.
So we can do that. I will try to do it.
Our goal was to first check that the MPI replacement is taking place.
Yeah, exactly.
And this was an issue with the E4SCL, but we have resolved that.
Okay. Thanks.
So Sarah, were you able to run the run.sh, and did you get the output that shows the execution?
I'm getting an error writing channel 3950 input output error.
Oh, really?
Yeah, I can put it in the chat if that's easier to look at. So yeah, it's in the chat now.
So this is the output I see. Error writing /channel.
Did I need to chmod something?
So it worked for me. Let me just see. I did the copy in the current directory from this file. And let me just make sure that the file permissions over here are okay. And here I see that it's able to copy everything in the current directory and run it from there.
Yeah, I don't know why it's not working. And then it's given me a whole bunch of other errors about cannot send after transport endpoint shutdown subsequently.
Alexis, is this run.sh working for you?
Yeah.
It worked for you? Yeah. And you too? So why would Sarah be facing the error? Sarah, you are on the $my_scratch directory, is that correct?
Yeah.
Do you know why she would face a write error? I cannot see your screen. Can or the chat message? Can somebody show what error she's seeing?
Look, it's not the end of the world if I can't get it to run. Probably, like I can follow along with your example. It might be not worth troubleshooting.
Okay, can somebody else on the online set of participants confirm that they were able to run the run.sh after doing the SLOC and that it worked properly in their my_scratch directory? Okay, Stephen, Angus. So the replacement is okay.
I didn't even SLOC, I just ran the.
So, Sarah, you get an error message saying what, or?
It's in the. I guess it's probably not on the.
So it's saying input/output error on a copy command.
On the copy command.
There is a copy of channel 395.
I'll put it. I just took a screenshot. I'll put it in our Slack. Maybe that's a bit easier to see.
Were you able to? Let me just see if there's a scratch directory.
And I think it's Sam is reporting that he also has some issues. Are these the same kind of issues, Sam? Or something else?
Channel OMPI is a directory that I got from your area.
So I put it in the SC uptake Slack, the screenshot.
Can someone maybe share with Samir the error message, guys? Marco, Basha, or Alexis, can you share that?
Yeah.
Are you able to try this?
Yeah, we were able to.
And did anyone else have any problems in replacing the MPI using E4SCL? Any questions on what we just did here?
I had the same, a similar problem that was inconsistent, but it was resolved when I had a new allocation. That's all.
And it worked for you as well then,
It
finally?
did. Yep.
It did, Sam. Okay.
Yep.
So just to recap, what we did here is we took an off-the-shelf container which had OpenMPI in it, and it had compiled the OpenFOAM binary. This was not a container that was built on a Cray system. This is what I was mentioning yesterday, that we now have the ability to build our containers on any platform and run them on any other platform. So you can now ship your applications as binaries with the help of a container. And then in that container, you just replace the MPI with the system MPI using E4S CL, the container launch tool. So you are able to just distribute your application in a container, even if it's built with a incompatible API for the MPI. Because OpenMPI is very different from Cray MPitch. And with this E4SCL tool, you can just take that off-the-shelf container and then launch it on Setonix and use it with the CPU nodes this way. Our next step would be to see if we can get support for GPUs and the AMD GPUs in particular, and see if we need to do some additional retooling while we launch these containers. And if we are able to do that, then we could take the Infinity Hub containers that AMD distributes with OpenMPI and then deploy them on Setonix using E4SCL. And that may take a few more days for us to reach that point. But at least we have the first set of containers, and it looks promising. Now, we will also look at running our graphical user interfaces. So to do that next with Tau and E4S, there are a couple of things I wanted to mention. And the first one is setup on Setonix. So we have remoteviz.pawsey.org.au, which allows us to launch a graphical user interface through our web browser. So pretty much like using DCV, we can do this, but I prefer if we use the native application that RemoteViz FastX provides. And so you may have to install this and download the FastX client like this. So first you go to the remoteviz.pawsey.org.au auth SSH, you launch the Xterm application, and then it will ask you to download this FastX client. Install this on your Windows or Mac, and then when you launch the Xterm, you can do the SSH-uppercase Y-Y to Setonix so that the X calls can get forwarded, and then you can use the Tau module, and we'll continue on from there like this. Okay, so let's go and try this one step at a time. First, we have to go to remoteviz.pawsey.org.au, just like it says on slide number 6. Now, I'm here on this other network. Will I need to do something special to go from the Pawsey guest network to go to this URL?
No, it should be fine.
It should be fine.
It's accessible from the outer world.
So I'll just go here. And I'll do an SSH login like this. Click proceed. It says no sessions running, and I'll click on the Xterm.
What's the username and password?
Your username password is the same one that you use on Setonix.
Okay.
And here I click on it. It will ask me for the password again. And then I click Submit. And it says desktop clients. And I have the desktop client installed already, but this is what it will do if you don't have that. And here is the session. Are you able to? Session is starting. There. So here I have the external. Disconnected sessions.
Yeah, I think you lost a couple of them. I think that's the reason why. You can close one of them.
Do I have to explicitly kill them? Disconnect or terminate? Okay. So I again launch the external?
Yeah. You get one session. I think. Refresh the page. Yeah.
Oh, I see. What happens is this is the pop-up that I need to click on. And then it says, so those who are using Safari, you might see the pop-up window over here that you have to enable. And then it says, how do you want to connect to your session? And then you click the desktop client or the browser client. I'm going to click the desktop client and it's going to check the installation and launch my desktop. Session not found.
Yeah. No.
You can use the browser client as well if you that will work and run entirely on the. It should run entirely.
It didn't.
Oh, there's no session.
Let me try it again. Start from scratch.
Yeah.
Here. It is starting. And now I should see a pop-up window over here.
Okay.
And then I click on connect and then it says allow and it will now work with the FastX.
Yeah.
I hope others online have been able to connect this way and launch the session. This is the FastX Web Connect. And here is FastX Web Connect, and it's not.
Is the session still?
Yeah, I think it is. Oh, no sessions running.
So if you refresh, you can see that.
Oh, it is
Oh,
there.
okay, now.
It's saying disconnected sessions.
Oh.
So something weird is going on with FastX. It seems to be launching it and then disconnecting it.
Try it over again, Samir, but with the browser option instead.
Session is starting. Browser client.
Yeah.
And can you try and refresh the screen again? Oh.
We don't have.
Ah.
Okay, let me try that again. This did work very well. Should I try with the desktop?
Yeah.
Session is starting. Let me see. Maybe it has something to do with the Wi-Fi network that I'm on, which does not allow direct connection.
Can you? So I was able to connect now with a desktop session. Browser client, and then of a desktop session.
And you are on the Pawsey get?
I am on the Pawsey. I am on Pawsey, but it should be the same.
Because I cannot SSH to Setonix directly from Pawsey get.
Yeah,
This is. Failed to disconnect session. Is it working for others in?
Alexis, did you use the port 3443? Or can you check the URL? The URL there on top. We have 3443 in the URL for the browser. But this is something.
I use the.
You have this. And one, Samir, which? Can you give the full URL, please? Yeah, I don't know. Can you try and go change the port? There might be an issue with the port we are using. So after, can you get rid of session, and then after AU just add :3443? And let's see if it goes better that way, because that's how I normally connect to remote base. So yeah, just log in again. Okay. Can you check if you're still on that port? Yes. Okay. Let's give it a go this way. Let's see. Then okay. Desktop. Okay. Then let's wait. And then open. Click on one, and then try.
Let me see.
I tried with browser. Browser was fine, but then.
Yeah, this is Web Connect is not doing that. But if I do a browser connect, yeah, I get a blank.
Even and the port is 3443 is still. Yeah. Okay.
Sorry, I was talking to Yatu, and he's mentioning there are so many sessions opened up, then there might be a license issue, so we need to close some.
That
Yeah.
would explain
No,
it.
maybe, yeah.
If everyone in the class is trying this, the license limit will disconnect the sessions. That would explain why when I was trying it in my hotel, it was fine because there's a license limit that's reached.
Let me quit. And
Yeah, I'm gonna quit my session as well.
yeah, so at least gives little to you to connect.
Maybe we yes. And also, Samir, I realize it's a bit it's a bit confusing, but when you have disconnected sessions, those are actually open. It just means that you are not connected. You are not watching the session, but I think these are still open sessions. So
I
all
have
of
to
those,
physically
yeah,
go and terminate it.
yeah, exactly.
I'll do that.
I didn't. They just changed the interface, so I didn't realize that because this is all new. It's a new
Yeah, you can try.
portal.
Okay, so I'll just try extern. There, it's starting. I can say web browser client. See, it's trying this URL, but it's just blank. So it's probably the limit on the number of sessions. In this case, we can just revert back to our session on AWS and see if we may be able to use that.
Online, Stephen's got, Stephen, would you like to unmute and?
I guess it doesn't matter so much if we're switching back to AWS. I was just having issues actually using the Xterm session. Like you try to type on the keyboard and maybe 1 in 20 key presses actually get through.
Oh, there was some problem with that FastX interface?
Yeah. I have to use it through, well, I was using it through Firefox on Linux because there's no Linux client that I saw.
Okay.
But yeah, if I use the on-screen keyboard within the Xterm session, that worked, but trying to actually type through didn't.
Okay, since there's some issues with the license anyway, let's just stick to this. Where we were was
Samir, the Wiz guy has asked me to try again. So yeah, otherwise you can continue with the Wiz empty session with the instance.
Okay. So can everybody log into the AWS nodes that they had allocated? Are you able to do that? There are a couple of new tools that I wanted to describe. And first of all, we have the Singularity container that we are running. And we saw how we do the replacement yesterday, but we can also just run the application with Tau inside the container. So here is the run.sh script. And I just say tau exec-ebs to run this Zoltan. And I can say run.sh in the Singularity container. How did I get into the Singularity container? Let me just start from scratch. I go to this tilde Zoltan and say Singularity run /ecp.simg. With this, I am in the Singularity container. I am in the Zoltan directory. I can say clean.sh, compile.sh, run.sh. And if you want to see what that run.sh script is, you can have a look at this. And when you do the run.sh, you will see that it's using tau exec-ebs on this Zoltan binary that we have created inside the container. Now this is running the application inside the container, and I can just say run.sh like this, and then launch paraprof. What is interesting about this container is that it has all the X libraries in it. It has the Java, it has Tau fully installed, and you can actually run the GUI from within the container itself. So we have bundled all of those dependencies in E4S so that you can have graphical user interfaces and all of these applications that are inside the container. So can everybody just try this? CD to the Zoltan directory, singularity run ~ecp.simg, go into the Zoltan directory, CD there, clean, compile, and run. This is another way of showing the integration of Tau within that container, where we have all of these applications. I hope you were able to run this with Tau exec, and that you generated the profile files, and then you are able to launch paraprof. At the end, it should say test passed, and then you should be able to launch paraprof directly from the container. So if I click on node 0, I can see exactly what's going on in node 0. Look at our thread statistics table. By right-clicking on this node 0, clicking thread statistics table, and so if you're looking at some applications and you're wondering whether the graphical user interfaces will work with the container, the answer is yes. You can have full GUI support inside the container. You can evaluate the performance of your applications inside the container like this. Warnings, you can ignore those warnings. They are just the just ignore those. And you can see this summary for this ePetra and see exactly where it's spending time in this code. So
Sorry, could you show the commands you ran again? My connection's a bit laggy, and so I didn't get to do them in time before you went to the next thing.
Absolutely. Let me just exit from here. Okay, so what I did is I first went to Zoltan directory. You have the terminal window, right?
Yep.
So you can CD to Zoltan, then you go singularity run ecp.simg. And this is in the home directory. Now you are in the Zoltan directory. You can say clean.sh, compile.sh, run.sh. And then you can say paraprof after that.
Okay. Awesome, thank you. I just missed the paraprof. I wasn't sure if there was something other.
Now,
so that's good.
just
Thank
the
you.
same thing that we were using yesterday. I'm just trying to show that when you have Tau in the container that you have, then you can just easily launch the Tau exec-ebs on any code that you build and run from within the container. And then you can look at the performance of that application like that. So here I'm doing the clean compile run and launching Paraprof from a scratch. And you can see the build over here. It will get all the libraries, some 43 odd libraries. And then we'll connect to Paraprof from within the container. And then we'll be able to run the analysis tool. You can ignore these critical warnings. You can just right click over here, node 0, and say show thread statistics table. And here I can again click here and see the inclusive time. I can expand this, maybe make this window bigger. I hope you're able to see the fonts properly. And then I can see the time spent in the rest of the application. And here it says that it's spending about 2.2 seconds in a function called ePetra FEV-BR matrix in global assemble. If I expand this, I should be able to see exactly where that code is. And if it's too big to fit in the window over here, you can always just expand this, right click over here on that actual code location, and say instead of show source code, if you say show function bar chart, it will wrap around the name of the function, and you'll be able to see that in this case it is in ePetra FEV-BR matrix.cpp at line number 388. It spent as much as 1.2 seconds in that line of code. So this is the advantage, that you can just take the application without any modifications. You just launch it with tau-exec-ebs. You can go down to the statement level and see exactly how much time it's spending in various functions. And all the functions, whether they are from the library or other. Here is a dot compute from d.c. That's called, there's Aztec OO, and all of these 43 libraries that are contributing to the solvers that this Zoltan application is using. What is interesting is that even if I'm in the container, I can still launch 3D graphics tools. And in the Singularity container, I should be able to then connect to this Windows and launch the 3D tool. So I just go to the 3D visualization, and then this will launch the Paraprof 3D view. And there it is. And I can go to the bar plot, and then you can see that I can rotate this view from within the Singularity container. So in terms of just packaging your software, this just shows you that if you have the right platform, you can create packages which use 3D graphics. You can include them in the Singularity container and then ship them. And this is running on AWS, still in Oregon. And I can run a Singularity container there and still have the 3D graphics work through the AWS DCV. So all of those things are working. And then we saw yesterday, and just to recap, that we can then use the E4SCL to actually run that application with different MPI providers. This was with the OpenMPI. Then I can just come out of it, and I have the Zoltan binary, and here is the Zoltan binary. I should be able to say run E4SCL mvaph2.sh. And then it will use the E4SCL, it will use the mvaph2x. It will create this, it will launch it, and it will run the workflow. And this is the same E4SCL tool that we are now using on Setonix. So can everyone just try something like this? Run E4SCL Intel MPI.sh and run E4SCL mvaph2.sh. Now, once you generate the profile files with the tau exec-ebs, you can pack them and give it a unique name. So I can say paraprof --pack zoltan 4p.ppk. So this is the profile file. I'm outside the container. I can then remove the profile files and then launch zoltan 4p.ppk with paraprof like this. So this is running paraprof on bare metal zoltan test case like we did before. The reason I bring up this ppk file is that I will next show a tool that allows us to use these ppk files and upload them to a database and then do cross-experiment analysis with the ppk files. Okay. So here is the ppk file, and